Okay, Algebra 1, I'm going to record half of the lesson for 3-5. We're only going to do half of this today because it is kind of long. There's about 8 examples, I think, but some of them are kind of long, and I'll talk about them a little bit. But we'll do half of this today, and then I'll give you what the assignment is, and then we'll add on to that tomorrow. So they're going to start talking about linear and nonlinear functions, but talking about like different things that happen with them, like in the shapes of the graphs. So one of the first things is symmetry, whether a function is symmetric or not. So like this first one has a line of symmetry. It has line symmetry. And this is the equation for a parabola. This is that y equals x squared. It's a quadratic function. We've talked about them before, how they look like a parabola. And this one, like if you were to fold it in half, it would be completely the same on both sides. And the place where you fold it in half just so happens to be the y-axis. Sometimes if you shifted left or right, it might not be exactly on that y-axis, and you'll see that here in the next section, but that is the y-axis. Now, sometimes instead of calling it the y-axis, they will call this the line x equals 0. This is the straight up and down line, x equals 0, right? Like if the parabola was over here and he was like across this line, that would be the line x equals -3 because it's going up and down on -3, right? So this is the line x equals 0, or the y-axis where you're folding him in half, okay? So down here we see a different function, and this, I don't know if you remember me talking about it yesterday. This is not a parabola. This is the function of y equals x to the 4th power, right? Because he has a couple little humps. He looks like a W, kind of. And he is x to the 4th power is what his function is. But he folds in half across this dotted line, right here. And that, if we look on the x-axis, is at the point -1. So that's x equals -1 is where he is folded across, okay? So this is a line symmetry and a vertical line other than the y-axis because he's shifted over and he's folded in half across the line x equals -1. So let's go down to example 1. It says determine, and there's I think 4 of these on example 1, so 4 different questions, I guess. This first one is a linear function that looks like a line, and so it's saying, like, is there a place where we can fold him in half? So, like, I'm looking at the y-axis, and if I fold this guy over to this guy, that one's going to look like this, right? And if I fold this over here, it's going to look like this. So he is not symmetric because if I fold him in half, he will not live or like lie on top of himself. So there is, I'm trying to figure out what goes in the blank. There is blank that can be drawn. There is no line, I'll just say no line, that can be drawn to make the right half a mirror image of the left half. So the function does not display a vertical line of symmetry, okay? That one does not have a line of symmetry. The second one over here, off to this side, that's that y equals x to the 4th power function again, because he looks like he's like an upside down W. Actually, he's technically negative x to the 4th power because he is flipped down. But he does have a line of symmetry, and it's like right here where it goes through that this bottom part, and that looks like it's at 1.5. So his line of symmetry is x equals 1.5. That's where the line is folding him in half. Okay, this one down here in this corner, that's a parabola again. That's y equals x squared. And this function, if I try to fold him in half, he would be across this dotted line. It's usually where that vertex is located. The bottom of a hill or a valley is called a vertex. Like this point right here would be a vertex. This is technically a vertex as well, but that's not where the line of symmetry is because this has more than just this side is, right? So the vertex is like the high or the low point, right? So this one is a vertex. It's going to go straight through that vertex, and that is at, if this is the y-axis, this is at -2. So x equals -2 is the line that we're going to fold him in half, okay? And then this one over here, this is actually the function y equals x to the 3rd power, okay? He goes in opposite directions, so that means he's an odd-powered function, like 3 or 5 or 7. They go the same direction, if they are an even powered function, like this one is an m, he's going the same direction, so he is a fourth powered function. This one is kind of fancy. We know that that's a linear function, which is y equals x, right, to the first power, and those are going opposite directions as well. Opposite means it's odd. The same direction means it's even. Okay, that's more than you needed to know. But anyway, so x to the third power is not going to have a line of symmetry, because when I try to fold him across that, he's not going to match up to himself. So there is no line that can be drawn to make the right half of the function a mirror image of the left half. So the function does not display any line symmetry. Okay. All right, so there's just a few functions, few examples of those. If we do this check, this is the equation, the absolute value of x. It looks like a V. It comes to kind of a point at the bottom. Okay, you don't need to know this, but the sooner you learn these, like these are called parent functions. If you learn these like sooner rather than later, it's going to make life easier for you when you get to algebra 2. But those are all called parent functions. So absolute value of x is what looks like this guy, okay? And if I fold him in half, he will fold in half right here where this vertex is again, okay? And that is at, if this is the y-axis, this is 1, 2, 3, that's at, does the function possess line symmetry? Yes. Describe the line symmetry. It is at, not y, it is at x equals 3. That straight up and down line is crossing through the x-axis right here. This is the x-axis. It's crossing through the x-axis at 3. That straight up and down line is, okay? All right, let's go down to example 2, and this has an actual story context to it. So a fountain is spraying a stream of water into the air. Okay, so we've got this. This is the fountain's streaming water, okay? Now, it says the solid portion, which is just this right here, is the path of the water, okay, where x is the distance in feet from the fountain. So this is the x-axis. This is my distance, and y represents the height. Okay, now the reason why they went ahead and they did graph the rest of this, but they put it as a dotted line because, we've talked about this before, you can't have a negative height and you can't have a negative distance. So they went ahead and did that so we could see that this is a parabola and look at its symmetry, but just know that like that's the reason why it's a dotted line rather than it being a solid line, is because that's not going to actually like be a part of the story, okay? Only this piece is going to end up being the path that the water is going to travel, okay? Find and interpret any symmetry in the graph. So the right half of the graph is the mirror image of the left half, and we need to figure out where that line symmetry happens. So he divides in half right here, I think, which is at x equals 2. Okay, in the context of this situation, the symmetry of I'm right here in this paragraph. In the context of this situation, the symmetry of the graph tells you that the height of the stream of water when it is from 0 to 2 feet away from the fountain is the blank. Oh, is the same as the height of the stream of water when it is from 2 to 4 feet away from the fountain. So from 0 to 2, let's see, what did it just say? The symmetry of the graph tells you that when it is from 0 to 2 feet, so 0 to 2 feet would be like this chunk right here, is the same as from 2 to 4 feet, okay? So like its height is the same on both of those pieces, both of those chunks, because it's doing, it's going up and it's coming back down in the same motion. This piece is the same as that piece, okay? So same goes in that blank there. The fountain is the same from 0 to 2 feet as it is from 2 to 4 feet, okay? I'm going to skip the check because that is... actually, let's do the check. The solid portion of the graph represents the path that a golf ball travels. So it looks like this. And it looks to me like the golf ball is being hit from like maybe 7 feet in the air, which kind of seems weird. The y is the height of the golf ball, and this is the distance. Okay, that's kind of weird. A golf ball, usually a golf ball's hit from the ground, so I don't know why they didn't start at 0 here and go up that way, but whatever. This is being hit from 5 feet, so maybe we're on a platform and we're hitting off of a platform, like in a golf, like a professional golfing place, okay? So height is about 7 or whatever it is, right? Use the graph to describe any symmetry. This is going to have symmetry. This is a parabola. This is a y equals x squared function. And it looks like if we would fold him in half, he would maybe be like here. I don't know, so not quite 100. 50 is there. 75 would be here, right at about that point. I don't think he's quite at 100, but it says it is symmetric in the y-axis. The y-axis is over here. That's not where his line of symmetry is, so that's wrong. Symmetric in the line x equals 8. X equals 8 would be like here, so that's not correct, okay? Symmetric in the line 28.25. That would be like here. Nope, that's not going to be it either. And symmetric in the line x equals 90. I think that's going to be the one, D. Okay, that's about where that line is at, a little before 100, okay? Interpret the symmetry in the context of the situation. Okay, so the height of the golf ball is part A, correct? The height of the golf ball when it travels a distance of 0 to 8 feet, from 0 to 8 feet in distance, is the same as from 8 to 28 feet. So from 0 to 8 feet would be like from here to here, like this little chunk of graph right here, is the same as 8 to 28 feet, which is there. No. That's not true. The height of the golf ball when it has traveled a distance of 0 to 90 feet is the same as 90 to 180 feet. 0 to 90 feet would be from here to here, right? 0 to 90 feet is the same as 90 to 180 feet right here. Okay? I think that's going to be the one, right? The distance, let's look at C. The distance the golf ball travels when it's 0 to 8 is the same as 8 to 28 feet. Oh no, wait, that's wrong. B. B says the height of the golf ball when it's traveled a distance of 0 to 90 feet. Oh no, that's right. And this one's D is similar to that, but it says the distance the golf ball has traveled when it's 0 to 90 feet in the air is the same as the distance the golf ball has traveled 90 to 180 feet in the air. We don't want to go off of the distance. We want to say this height right here is the same as this height, okay? Because we're looking at what's happening to the y-axis in between 0 and 90 to 180, okay? So we do want to look at height. So B is going to be the correct answer, not D or C. So yeah, okay, there we go. All right, let's talk about a couple more things and then we will stop for the day. One thing is circle this word, extrema. Okay, extrema, I see the word extreme in there, and that's true. That's what it means. When we're looking for extrema, we're looking for maximums and minimums. Okay, so like high points and low points. And these are called relative maximums and relative minimums. And the reason why we put relatives in front of that word is because it's not absolutely the maximum point all the way through on the graph, right? Like points over here are higher than this point right here. But relative means the around you, right? Like your relatives are the people around you. So in relationship to the points around it, right, close to it, it is a high point. In relationship to the points around it, it's a low point. So relative to that point, right? This is not the absolute lowest point because there's lower points down here if that continues on forever. But relative to the ones around it, it is a high point, and relative, it is a low point, okay? And those are called extrema. Extrema is like the plural for maxes or maximums and minimums, okay? So that's how that works. Now, they also have where a function is increasing and decreasing, okay? So let's say this place right here on the x-axis was like at -2, and let's say that this was at +2, okay? So what we would do here is we would say that it is, we'll talk about increasing versus decreasing, okay? We're looking at the graph from left to right, and it's like if I'm driving a car along this graph, right? Here's my car. Okay, and I'm driving it left to right like we read a paper, right? First thing I'm going to do is I'm going to decrease, okay? So he is decreasing when x is on this side of -2. So when x is less than -2, it's decreasing, okay? And then from this guy to this guy, he is going uphill. So he is increasing between -2 and 2, okay? And then he turns around and he starts going back down again and decreasing. And that is when x is on this side of positive 2. So x is greater than 2, he's going to be decreasing, right? At this mark right here, he starts to decrease again. So we're looking at increasing and we're looking at decreasing and labeling what those are, all right? So that's what example 3 is going to look like. Determine where f is increasing or decreasing, okay? So what's happening is we start our car right here, and we're going along, we're going along, we're going along, and we are decreasing, decreasing, decreasing until I get to this point, okay? And on the x-axis, that is at 0, right? Okay, so when x is on this side of 0, or in other words, less than 0, the graph goes up when viewed from left to right. So the function is increasing. Oh, I don't like that. I was doing decreasing first. Blah, blah, blah. Decreasing, this goes down here. When x is less than 0, the graph goes down when viewed from left to right. So the function is decreasing for x is less than 0. Okay, I always read the graph from left to right. Okay, they're starting with increasing. So here it is increasing, and that's on this side of 0, right? So when x is greater than 0, it's going up, and it's increasing when x is greater than 0. So going up means it's increasing. Going down means it's decreasing, okay? So we're just kind of splitting the graph into the chunks of what's happening to it from left to right, okay? All right, so let's go to this next one, and then maybe we'll stop. We'll do a check, actually. Yep, we'll stop after example 4. Sorry, I'm making you dizzy. It says determine the extrema. Extrema, again, are those maximums and minimums, okay, of f of x. Then identify each point as a relative max or a relative min. So I've got one right here. I've got a point right here. They also have like a point labeled here and a point labeled there, but those are not going to be maximums or minimums. Those are just going to be like points that are on the graph. So the 2 orange ones that I have here are going to be my maxes and mins. So the extrema are these 2. This point right here is at -2, 4, and this one right here is at 0, 0. Okay, now I'm going to label them. This one is a high point, so he is a relative max, if you want to just write it like that. Okay, this one is a relative min. He is a low point on my graph. Okay, so it says determine the extrema, that's these 2, and identify each point as a relative max or min. That's this point right here. So I've answered both parts of the question. Okay, so there is how that works. Extrema, point this one and point this one, that's my -2, 4, and 0, 0 are located are locations of relatively high or low value, so they are the extrema. The minimum, no other points nearby point, this is minimum, right, is 0, 0, have a lesser y coordinate. So point 0, 0 is a relative min. No other points nearby point -2, 4 have a higher y coordinate. So point -2, 4 is a relative maximum, okay? All right, same thing here. Let's do the check, but I think there's an A, B, C, D. It says which points are relative minimum. Select all that apply. So low points. All right, so let's look at A. Is A low point? No. Is B a low point? Yes. So I'm going to circle B. B is a relative minimum. Is C a relative minimum? C is a relative maximum. That's a high point, so it's not going to be C. Okay. D is a low point. He is a relative minimum. Okay, so I'm going to circle him. And then E is not a maximum or a minimum. A and E are not maximums or minimums. So just B and D for those. Okay. All right, so that was kind of a lot of information. It's kind of a long section. So we will start up again tomorrow with example 5 and continue on from there. But I want you to do for homework, I want you to do 1 through 14 all. Okay, the first page, or most of the first page, I guess, is just figuring out what that line of symmetry is. And that doesn't take very long. Actually, most of these questions don't take very long, actually. So this one is increasing, decreasing. Make sure you pay attention to this heading right here. If you get stuck and you're like, I don't even know where to start, increasing, decreasing, you just do it exactly like we did example 3. Okay, whatever we wrote down, that's what you're looking for for example 3. Okay, same thing here. Example 2 is kind of what these two problems are going to look like. So refer back to those if you get stuck, or help each other. Okay, that is totally fine. But do 1 through 14, that first page, all of them, and we will add to that a little bit more tomorrow. We'll do some more of the ones down here for tomorrow. But there is that. Okay, 1 through 14 all. Goodbye.